Okay, today's lesson is about inequalities and their graphs. This is a new chapter, a new beginning. Don't be defeated if your grade isn't what you want. Get motivated and let's aim high. We're going to get good grades this time. We've got to apply ourselves. So anyway, the objective for today is to write, graph, and identify solutions of inequalities. And this is preparing you for standard RAI 3, which is to solve linear equations and inequalities in one variable. So we've already looked at equations, and so this is basically the same process, only now we're using inequality. So there will be a little bit of changes, but it's still along the same idea. So if you didn't understand equations, you get a second chance at it, I guess, solving equations, and now we're going to look at solving inequalities. So which number is above the less than symbol? If you look at each of those, the first one is greater than or equal to, the second one is less than, the third one is greater than, and then the fourth one is less than or equal to. So the number 2 is above the less than symbol. And I like to think of it as making an L with my finger, L for less than, and then I kind of squish it, look at it, a less than symbol. I don't know if that works for anybody else, but that works for me, so just an option. Okay, write an inequality to represent the verbal expression. We're looking at all real numbers, x, so we know we've got the real number x, and we want it to be less than or equal to -7. So that's all there is to it, just changing it from words into symbols. Any number x less than or equal to -7. Okay, so this one says 6 less than a number k is greater than 13. So 6 less than a number k. So that means I've got this k, and then I've got 6 fewer than it. So k take away 6 is greater than, this is my greater than symbol, 13. 6 less than a number k, so 6 fewer than k, is greater than 13. And earlier this year we had a lot of trouble with that. People see the 6 less than a number k and they just want to put 6 minus k. But we have to know how many we have to begin with to be able to say that I have 6 fewer than that. And think of it in real terms. Let's say I have 6 less than a number 12. If I say I have 6 less than 12, then I know that I have 12 take away 6, which is 6. If you write it the other way and say 6 take away 12, then that would be -6, and that doesn't make sense. 6 less than 12 would not be -6, it would be a +6. So it works the same way with 6 less than a number k. It is k take away 6, and then that value is greater than 13. So this entire value here is greater than the 13. Okay, so I use solid bullets when, hopefully you know this, when there's an equal sign in there. So if it's less than or equal to, or if it's greater than or equal to, I use solid bullets. And I think of it as there's more to the sign, so there's more to the line that's filled in. The line has a bullet to circle. There's more to the sign, there's the less than and the equal to, so I've got to show that more by filling in the circle. I'm showing that it's including that point. I use clear bullets if it's just less than or greater than with no equal to. So this first statement means x is less than 3. The next one means x is less than or equal to 3. We've got x is greater than 3 and x is greater than or equal to 3. Okay, this is a little flip chart that I was going to pass you out, but I don't think you guys will need it. This is just a review, but if you do want it, let me know. I just wanted to put the symbol, less than, and then underneath of it, you could give an example of each. And then we've got this symbol down here, which means not equal to. Okay, when we're talking about inequalities, order matters. We can't change the order of the things without changing the symbol. So what I'm talking about is, first we usually like to have our variable, then we have the inequality symbol, and then we have a constant. Okay? I think of this as flip-flops. if I have to flip-flop the sides of the inequality, I also have to flip-flop the inequality symbol. For example, if I change this from being x first and the constant last, then I've also got to change that inequality symbol there in the middle. For example, if I say x is greater than b, we know to write 11 is greater than b, the greater than symbol. Well, if I flip-flop the b in the 11 places, then I have to flip-flop the symbol as well. So I say b is less than 11, and that makes sense. If we said that b was equal to 2, okay, 11 is greater than 2, and it's also true that 2 is less than 11. See, I changed these two places down here, so I had to flip my inequality symbol to keep the statement true. So think of it as flip-flops. If we change the order, then we also have to change the sign. If we flip-flop the order or flip-flop the sides, we have to flip-flop the symbol. Okay, so we have to write an inequality that represents the graph. Well, I know that this one's filled in, so we know that it's including -1. So we're looking at all the x values, something with -1 and including -1. Well, since it's pointing towards the right, we know that it's including all the values that are larger than -1 or greater than -1. So this says x is greater than or equal to -1. So my value of x could be -1, it could be 0, it could be 1, it could be 2, it could be out here at 10, it could be any of those values greater than -1. And it could also be all of these little fractional pieces in between as well. Okay, the next one says, let's look at the graph. We're here at 4, but we're not including 4. So we know that we want to start at 4. And we're looking at all the x's to the left of 4. So that would be all the x values smaller than 4. But I don't want to include 4. And so a lot of times people want to say, okay, well, x is less than or equal to 3. Well, that's true, but then that doesn't take into account all of these little values in between 4 and 3. So that doesn't work. We have to start at 4, and we show that we're not including 4 by using the not equal to. We just use the less than. So 4 is all of the value, or x is all the values that are smaller than 4, not including 4. So that means it could be 3.9 repeating. It could be 3.8. It could be 3.7. That's why I can't start it at 3. I have to actually start it here on the 4. Okay, let's look at the next one. Same type of problem. It's all of the values of x that are to the left of -3, and we know we're not including -3. So it's all the values of x less than -3. And this very last one, we're looking at values of x that are to the right. That means they're bigger than 0, and they could be equal to 0 because it's included. It's a filled-in circle. Okay, so what inequality describes the following situation? Be sure to define a variable. So it says trail rides starting at $19.99. So we need to define our variable to begin with. So we need to let C equal the cost of the trail ride in dollars. So then how would I make an inequality to show that trail rides start at $19.99? Well, the cost could be $19.99, or it could be more than $19.99. So we could say the cost is greater than or equal to $19.99. Okay, and what inequality describes the situation? Be sure to define a variable. This is something that a lot of people apparently don't really realize what this means. It doesn't mean that it's 45 or higher. It means that it's 45 or less. You can go less than the speed limit. You might get the horn blown at you quite a bit. It might aggravate some people, but you do not have to go exactly 45. You can go under 45. But we all know that if you go over 45 and you get caught, you're going to get a ticket. So let's define our variable. We'll let S equal the legal speed in miles per hour. And so the sign then indicates that we can go less than 45 miles per hour, or we can go exactly 45 miles per hour. So the speed is less than or equal to 45 miles per hour. Okay, so just to kind of recap what we were talking about, we were looking at solving inequalities, just very basic inequalities. Actually, we weren't even solving, we're mostly just writing today. But we were talking about solutions a little bit too. The solution of inequality is any number that makes the inequality true. So before, when we were doing equations, we had one exact answer. The variable was equal to one exact value. This time the variable is equal to multiple things. It could be lots of values. It's anything less than or equal to 45. So it could be 45, it could be 43, it could be 42, it could be 41, 40, 39. I could keep on going. So there's more than one solution, but we show those solutions by using the correct inequality symbol. So keep that in mind as you are moving through this chapter. There's going to be multiple answers, and we show those multiple answers by using the inequality symbol. The other thing to keep in mind is that if you flip-flop the problem, the inequality problem, so here we have S is less than or equal to 45. If I want to change that to say 45 is something to S, then I must also, since I flip-flop the sides of the inequality, I've got to flip-flop this way. So 45 is greater than or equal to S. And notice the mouth was open towards the 45, and down here the mouth is still open towards the 45 because 45 is the largest value that we can have here.